The next item on the agenda is an information item to provide us with the 2015 Regulatory Oversight Report for nuclear processing, small research reactors, and Class 1B accelerators facilities as outlined in CMD 1643 and 1643.A. The public was invited to comment in writing. The Commission received one submission. Representatives from the licensees are in attendance, so welcome to all of you here. And they will be provided with an opportunity to make short presentation and will be available for answering questions. Also available to answer questions via teleconference, we have a representative from other licensees. So the presentation will be in 4 parts based on the 4 sections of the report. Part 1 includes the uranium processing facilities and the intervention from Northwatch. Part 2, 3, and 4 will follow after the rounds of questions on Part 1 and a health break. So, I think we'll start hearing from Cnsc, and Ms. Tadros, you're going to start. You're doing the honor. Over to you.
Thank you, sir. And good afternoon, Mr. President, members of the Commission. My name is Heidi Tadros. I'm the Director General of the Directorate of Nuclear Cycle and Facilities Regulation. And sharing with me today in the delivery of this presentation are my colleagues who I'll go through for all of the 4 parts that you're here today. So you know Ms. Kavita Murthy, Director of the Nuclear Processing Facilities Division. In the back row, Mr. Jean Leclerc, Director of the Nuclear Laboratories Research Reactors Division. With him also is Mr. Mark Berders, Director of the Accelerators and Class 2 Facilities Division. We have to our right here, who will be delivering the first part of the presentation, Mr. Lester Posada, Project Officer and the Project Lead for this Regulatory Oversight Report. And in the second row behind me, we have Mr. Benjamin Priere and Mr. Robert Buer. Both are project officers and inspectors working in the Nuclear Processing Facilities Division. So with that, we have colleagues who will be supporting, subject matter experts, technical experts, who will be supporting and answering questions the Commission may have. And as rightly noted, we are here to present Commission Member Document 16-M43, titled Regulatory Oversight Report for Nuclear Processing, Small Research Reactor, and Class 1B Accelerator Facilities, 2015. On this next slide, before we get into our presentation, I'd like to draw your attention to a few errors that were noted after the CMD was put together, and I'd like to walk you through those corrections. They will be pertinent should your questions come there. So on page 23, second paragraph of staff's CMD, there is missing text in the paragraph that is highlighted in bold in the first bullet of our slide. On page 187, table D4, there's a missing 0 on the financial guarantee amount for Triumph. The correct value is $10,800,000. On page 202, table F18, columns representing 2011 and 2015 air emission results for Triumph. These values have been updated with the values that you currently see on this slide. Please note that these changes do not impact Cnsc staff's overall conclusion on the performance of the facilities discussed in this report. These errors will be corrected in the final version, and we do apologize for any confusion. So this next slide positions Cnsc's regulatory oversight reports. This is the third of 5 RORs that Cnsc staff present to the Commission in public proceedings. The reports for the nuclear power plants and use of nuclear substances were presented in August and September 2016, respectively. The final 2 reports will be presented in December of this year. Regulatory oversight reports are reports on the safety performance of activities and facilities regulated by the CNSC. I will now pass the presentation to my colleague, Ms. Kavita Murthy.
Good afternoon, Mr. President and members of the Commission. My name is Kavita Murthy, and I am the Director of the Nuclear Processing Facilities Division at the Canadian Nuclear Safety Commission. Our presentation today starts with a brief overview of how the CNSC rates licensee performance and how we provide risk-informed regulatory oversight. This is followed by safety performance highlights for each facility. Where relevant, we have also included updates on specific information that was requested by the Commission during last year's presentation. Finally, we provide CNSC staff's conclusions for the performance of uranium processing, nuclear substance processing, small research reactor, and Class 1B accelerator facilities in 2015. The Canadian Nuclear Safety Commission regulates Canada's nuclear processing, small research reactor, and Class 1B accelerator facilities to protect the health, safety, and security of Canadians and the environment. The CNSC achieves this mandate by licensing these facilities and providing regulatory oversight through compliance inspections and desktop reviews. A licensee's performance is measured by the ability to carry out its licensed activities safely, minimize the risks posed by the licensed activity, and by its ability to operate in compliance with all regulatory requirements. CNSC staff use 14 safety and control areas, or SCAs, to evaluate each licensee's performance. The SCAs are listed on the right hand of this slide. Safety and control areas are technical topics that CNSC staff use across all regulated facilities and activities to assess, evaluate, review, verify, and report on regulatory requirements and performance. Each safety and control area has an associated rating, which could be fully satisfactory, satisfactory, below expectations, or unacceptable. Licensing and compliance activities enable the CNSC to provide assurance to Canadians of the continuing safety performance of licensees. The framework for regulating licensed activities at the CNSC applies a risk-informed approach considering the level of risk associated with each facility across 14 safety and control areas. Compliance activities associated with a given safety and control area are commensurate with the risk associated with it. The level of risk is reflected in CNSC staff's facility-specific compliance plan, which includes the number and scope of inspections and reviews of operational activities and licensees' reports. Areas that are more significant to safety, such as worker radiation dose control and effluent and emission monitoring, are subject to more frequent and in-depth verification. Compliance plans are continuously reviewed and revised to take into consideration changes in licensees' performance and lessons learned. To complement these activities, CNSC staff also conduct independent environmental monitoring in and around licensed facilities. Separate from, but complementary to, the CNSC's existing compliance verification program is the CNSC's Independent Environmental Monitoring Program. The CNSC conducts independent environmental monitoring to verify that the public and the environment around CNSC-regulated nuclear facilities are not adversely affected by releases to the environment. This verification is achieved through independent sampling and analysis by CNSC staff of the air, water, soil, vegetation, and various foods. This slide shows where CNSC has conducted independent environmental monitoring in 2014 and 2015, and also those that are planned for 2016. The facilities scheduled for independent environmental monitoring program sampling in 2016 have in fact been surveyed already, but the sample and data analysis are ongoing. After the data is collected and analyzed, all of the monitoring results are posted on the CNSC's website. The results from Independent Environmental Monitoring Program demonstrate that the licensee's environmental programs are effective. The report provided in Commission Member Document 16-M43 and this presentation are organized by industry sector, covering uranium processing facilities first, followed by nuclear substance processing facilities, then small research reactor facilities, and finally the Class 1B accelerator facilities. Performance data for all 14 safety and control areas for each facility is summarized in the overview section of the corresponding industry sector. Here, you will find detailed performance reporting for 3 safety and control areas: radiation protection, environmental protection, and conventional health and safety. These SCAs cover key performance indicators for nuclear processing, small research reactor, and Class 1B accelerator facilities. In the facility-specific sector, we provide performance data, events, and highlights for 2015, trending data for the facility, and identify areas of increased regulatory focus where relevant. As the President mentioned, information about this meeting was made public by the CNSC starting in March 2016, and to support public participation, participant funding of up to $25,000 was offered to interveners through the CNSC's participant funding program. CNSC staff CMD was made available to the public on September 4th. Written interventions were accepted until October 3rd. Participant funding was awarded to Northwatch, who has a written submission today. Also submitted as interventions are the midterm reports for the 3 uranium processing facilities listed on this slide. This completes the introductory part of the presentation. I'll now pass the presentation to Lester Posada, who will continue with the uranium processing facilities overview.
Thank you, Ms. Murthy. Good afternoon, Mr. President and members of the Commission. For the record, my name is Lester Posada, and I am a project officer working in the Nuclear Processing Facilities Division and the project coordinator for this regulatory oversight report. I will now present CNSC staff's assessment on the performance of the uranium processing facilities. The nuclear fuel cycle begins with uranium being extracted from the ground and ends with its disposal following its use in the generation of energy. The term cradle to grave is commonly used to describe the nuclear fuel cycle. The front end of the nuclear fuel cycle starts with uranium mining, followed by milling, refining, conversion, and in the case of Canada, fuel manufacturing. The uranium processing facilities discussed in this report are all located within the province of Ontario, as shown in this slide, and conduct refining, conversion, and fuel manufacturing activities. Cameco's Port Hope conversion facility is included in this report, but was the subject of a license renewal hearing earlier this week. Therefore, we will not be discussing its performance in detail within this presentation. This table shows the licensing and compliance effort from CNSC staff in 2015 for uranium processing facilities. In 2015, CNSC staff spent 211 person days on licensing activities at the uranium processing facilities. There were no license amendments for any of the facilities. However, considerable effort was spent on modernizing the license conditions handbooks for these facilities. 1,269 person days were dedicated to compliance activities in 2015. This was accomplished through inspections, desktop reviews of activities and processes, and through the review of licensee reports. CNSC staff performed 15 compliance inspections at the uranium processing facilities. Findings resulting from these inspections were provided to the licensee immediately in preliminary reports, followed by detailed inspection reports. All enforcement actions arising from the findings are recorded in the CNSC Regulatory Information Bank to ensure that all enforcement actions are tracked to completion. The 2015 performance ratings for each of the 14 safety and control areas were determined by Cnsc staff based on the results and observations from inspections and desktop reviews. For 2015, all of the uranium processing facilities received a satisfactory rating in all safety and control areas. The trend remains largely unchanged from previous years, with a few exceptions. In 2015, the Blind River Refinery continued to receive a rating of fully satisfactory for the conventional health and safety and control area, in recognition of 9 continuous years without a worker lost time injury. GE Hitachi's rating for environmental protection was changed from fully satisfactory to satisfactory as a result of an overall assessment of its program during 2015. Overall, these ratings indicate an adequate management of safety and control measures at all facilities. The graph on this slide shows the average and maximum individual effective doses in 2015 for all uranium processing facilities. The red line on this chart displays the 50 millisievert regulatory effective dose limit that a nuclear energy worker can receive in a year. No worker received a dose in excess of the annual effective regulatory dose limit. The maximum effective dose by any worker in any uranium processing facility was 12.6 millisieverts, which represents 25.2% of the annual dose limit. In 2015, radiation doses received by nuclear energy workers in the uranium processing facilities was effectively controlled. This slide provides the estimated dose to the public from each uranium processing facility from 2011 to 2015. Doses to the public are conservatively estimated from all uranium processing facilities, primarily by gamma dose rate measurements, air emissions, and effluent releases as applicable. Estimated doses continue to be well below the regulatory limit of 1 millisieverts per year. To confirm the effectiveness of emission abatement systems and to monitor the impact of uranium emissions from the facility on the environment, facilities operate high-volume air samplers. The green line on this chart displays the Ontario Ministry of the Environment and Climate Change standard for uranium in ambient air that took effect on July 1, 2016. The results from the high-volume samplers from 2011 to 2015 are shown in this slide and indicate that a maximum annual average concentration of uranium in ambient air measured around any uranium processing facility was much less than the ambient air standard for uranium and indicate that the environment and people are protected from airborne releases. A risk assessment of GE Hitachi Canada's Peterborough facility has demonstrated that ambient air sampling is not required since the measured releases from the stack already result in levels lower than the air quality standard. Soil monitoring programs are intended to monitor the long-term effects of air emissions to show whether there is an accumulation of uranium in soil in the vicinity of the facility. The green line on this chart displays the Canadian Council of Ministers of the Environment's guideline of 23 micrograms per gram uranium for residential and parkland land use. The chart also shows the annual average uranium concentrations in soil. The data for all facilities is well below the provincial guideline. Soil sampling results in 2015 continue to indicate that current uranium emissions from the uranium processing facilities are not resulting in levels observed in soils that would pose a risk to people or to the environment. Note that due to extremely low stack emissions at GE Hitachi Peterborough, soil monitoring is not warranted. Also note that the chemical fuel manufacturing samples soil on a 3-year frequency. The next chemical fuel manufacturing soil samples will be collected in 2016 and reported in next year's regulatory oversight report. A key indicator on the performance of a facility's conventional health and safety program is the number of lost time injuries that occur at the facility. A lost time injury is an injury or illness resulting in lost days beyond the date of injury as a direct result of an occupational injury or illness incident. As shown in this slide, the number of recordable lost time injuries in 2015 at uranium processing facilities was low. Because the frequency of lost time injuries have always been low at these facilities, there are no trends with respect to the number of lost time injuries reported to the CNSC. CNSC staff conclude that the uranium processing facility licensees have been implementing their conventional health and safety programs satisfactorily during 2015, and that their programs are effective in protecting the health and safety of persons working in their facilities. This completes the overview of the uranium processing facilities. I would now like to pass the presentation to Mr. Benjamin Prieur, who will continue the presentation with the facility-specific performance of the uranium processing facilities. Thank you.
Thank you, Mr. Posada. Good afternoon, Mr. President and members of the Commission. My name is Benjamin Prieur, and I'm a Senior Project Officer in the Nuclear Processing Facilities Division. I've been an inspector with the Canadian Nuclear Safety Commission since 2008, and I'm the lead inspector and project officer for the Cameco Port Hope Conversion Facility. In the next few slides, I will introduce and provide some specific highlights for each uranium processing facility for 2015, starting with Cameco's Blind River Refinery. Cameco's Blind River Refinery is a Class 1B nuclear facility located in Blind River, Ontario. The Blind River Refinery's operating license is valid from March 1st, 2012 to February 28, 2022. The facility is located 200 kilometers north of Sudbury, Ontario, on the north shore of Lake Huron. Cameco's Blind River Refinery receives uranium concentrates from mines and mills worldwide. The yellow cake is then refined to produce uranium trioxide, which is an intermediate step in the uranium conversion process. In 2015, there were no major modifications to the Blind River Refinery facility that required Commission approval. Cameco made improvements to the site by constructing a berm around the facility for flood protection. The berm was designed to mitigate the impact of a flood caused by severe weather. The flood scenario was identified following Cameco's Fukushima Defense in-depth review against external hazards, severe accident scenarios, and emergency preparedness procedures. Cnsc staff conduct outreach activities on a regular basis, including recent meetings with the Mississauga First Nation. The Mississauga First Nation is the closest community to the Blind River Refinery and is located approximately 1 kilometer from the refinery. On October 6, 2015, Cnsc staff met with the Mississauga First Nations Lands and Resource Committee, staff, and community elders. Cnsc staff gave a presentation including information on the refinery's operational performance for 2014 and the results of the Cnsc staff's 2013 and 2014 Independent Environmental Monitoring Program. This meeting was supported by the Cnsc's Participant Funding Program. In 2015, there were no environmental license limit or action level exceedances at the Blind River Refinery. Cameco has implemented an effective occupational health and safety program, which has resulted in the refinery's ability to keep their workers safe from occupational injuries. The refinery achieved 10 years without a lost time accident as of June 2016. There were no radiation action level exceedants at the Blind River Refinery in 2015. CNSC staff are satisfied that Cameco continues to protect the health and safety of workers and the environment, and that Refinery continues to operate in accordance with the requirements of their license. This concludes the section on Cameco's Blind River Refinery. I will now introduce and discuss Cameco Portal Conversion Facility in the next slide. Cameco's Port Hope Conversion Facility is located in the municipality of Port Hope, Ontario, and processes uranium trioxide from the Blind River Refinery into either uranium dioxide for use in the manufacturing of CANDU reactor fuel or uranium hexafluoride. Uranium hexafluoride is exported by Cameco for further processing, later used as fuel in light water reactors. Cameco's Port Hope Conversion Facility has been discussed earlier this week during the license renewal hearing. I will skip through slides 28 through 31 and move on to slide 32 of this presentation, which focuses on Cameco fuel manufacturing. CNSC staff's complete review of the Port Hope Conversion Facility is available in the 2015 Regulatory Oversight Report for nuclear processing, small research reactor, and Class 1B accelerator facilities. Cameco Fuel Manufacturing is located in the municipality of Port Hope, Ontario, and processes uranium dioxide powder into natural uranium pellets and manufacture CANDU nuclear fuel in the form of natural uranium fuel bundles. In 2015, Cameco implemented several improvements to the fuel manufacturing facility and its equipment, including improvements to ventilation systems, furnace upgrades, and the commissioning of new uranium dioxide powder receiving and powder preparation area, which is an automated process. The upgrades to the fuel manufacturing facility resulted in overall improvements to the safety of the facility. In 2015, there were 2 confirmed instances where action levels were reached. Both exceedances were reported to the CNSC and investigated by Cameco. Corrective actions were also established. Cameco determined that the cause of the first action level exceedance was related to inappropriate use of respirators, as the worker in question was not clean-shaven. One of the corrective measures included improved communication regarding proper usage of respirators. In the second instance, Cameco determined the action level exceedance was in fact a non-personal exposure resulting from a contaminated dosimeter. In both instances, Cameco reported, investigated, and implemented corrective actions within a time frame accepted by CNSC staff. It is important to note that all workers' radiological dose were well below the corresponding CNSC regulatory dose limits, and there were no risks to their health and safety as a result of these action level exceedances. In 2015, Cameco Fuel Manufacturing did not exceed any environmental action levels. There was one lost time injury in 2015, however, where a contractor was injured while working in a tight space that was not a normal working space. This resulted in a 1-day loss of time. CNSC staff reviewed and accepted Cameco's corrective actions. Staff are satisfied that chemical fuel manufacturing continues to protect the health and safety of workers and the environment. This concludes the section on chemical fuel manufacturing. I will now introduce and discuss GE Hitachi Nuclear Energy Canada Incorporated facilities in Toronto and Peterborough. GE Hitachi Nuclear Energy Canada Incorporated, or GEHC, processes uranium dioxide powder from Cameco's Port Hope conversion facility into natural uranium pellets at its Toronto facility and assembles the CANDU nuclear fuel in the form of natural uranium fuel bundles at its Peterborough facility. In 2015, there were changes to key management positions at GEHC, including the retirement of its president and chief executive officer and a new appointment to the same position. In addition, improvements to plant equipment and processes, including upgrades to the loading dock in the Peterborough facility and natural gas supply upgrades, including header and piping replacements in the Toronto facility. GEHC also completed the implementation of a new systematic approach to training process and associated procedures to align with the Canadian Nuclear Safety Commission's Reg Doc 2.2.2 personnel training. In 2015, CNSC staff conducted a focused inspection of GEHC's environmental protection program. As a result, areas of improvement were identified, leading to the change in the safety and control area rating for environmental protection from fully satisfactory to satisfactory. None of the findings from the inspection posed an immediate or unreasonable risk to persons and the environment. GEHC developed a comprehensive corrective action plan, and CNSC staff are monitoring its implementation. In March 2015, CNSC staff directed GEHC's management to address identified deficiencies related to its public information program. In June of 2015, GEHC provided a 29-point improvement plan to ensure adequate engagement and communications with the local community near its Toronto and Peterborough facilities. A new position of Senior Manager, Community Relations and Communications was created as part of this improvement plan, and all improvement activities were completed by December 2015. CNSC staff continues to maintain increased oversight on GEHC's progress, including participation in its Community Liaison Committee meetings and presence during community outreach events in 2016. For 2015, CNSC staff assess that GEHC's implementation of its improvement plan for public information and disclosure is satisfactory. In August 2016, GEHC notified the CNSC of its sale to BWXT Nuclear Energy Canada Incorporated. CNSC staff is currently reviewing the application for the license transfer. CNSC staff recommendations will be presented to the Commission for consideration in December 2016. In 2015, there were no regulatory limit or action level exceedances at GEHC. There were no lost time injuries in 2015. CNSC staff are satisfied that GEHC continues to protect the health and safety of workers, the public, and the environment. This completes CNSC staff's performance review of the uranium processing facilities in Canada. I will now pause the presentation at this point, and we are available for any questions that the Commission may have.
So we will now proceed with part 2 of the presentation on section 2 of the report regarding nuclear substance processing facilities. CNSC staff, please continue.
Thank you, Mr. President, members of the Commission. Haiti Tadros for the record. So for this next section that relates to the performance of the nuclear substance processing facilities in Canada, I would like to pass the presentation on to Mr. Robert Buer, our project officer.
Thank you and good morning, or good afternoon, Mr. President, members of the Commission. My name is Robert Buer. I'm a project officer in the Nuclear Processing Facilities Division. I'll be presenting the next part of this presentation on the performance of the nuclear substance processing facilities. These facilities are different from the uranium processing facilities that we just discussed, as the end products are not related to the nuclear fuel cycle. The products created by nuclear substance processing facilities have a variety of end uses, such as diagnosing and treating cancer, sterilizing single-use medical equipment, and creating self-luminescent emergency exit signs for buildings and airplanes. There are 3 nuclear substance processing facilities in Canada, all of which are located in the province of Ontario. SRB Technologies is a gaseous tritium light source manufacturing facility located in Pembroke. Nordion Canada Incorporated is a health science organization that manufactures gamma sterilization irradiators for the large-scale irradiation of food, medical equipment, and cosmetics. Nordion also manufactures medical isotopes for diagnosing and treating disease. Best Saratronics Limited manufactures teletherapy machines, self-shielded irradiators, and small cyclotrons. Both Nordion and Best Saratronics are located in Ottawa. This table shows the licensing and compliance effort from CNSC staff in 2015. CNSC staff spent 566 person days on licensing activities at nuclear substance processing facilities. The license for SRB Technologies and Nordion were renewed by the Commission in 2015. 499 person days were dedicated to compliance activities. This was accomplished through inspections, desktop reviews, and through the review of licensee reports. CNSC staff performed a total of 9 compliance inspections at these facilities. All the findings resulting from the inspections were provided to the licensee immediately in preliminary reports, followed by detailed inspection reports. All enforcement actions arising from the findings are recorded in the Cnsc Regulatory Information Bank to ensure all enforcement actions are tracked to completion. The performance ratings for each safety and control area was determined by CNSC staff based on the results and observations from inspections and desktop reviews. SRB Technologies' conventional health and safety program continues to be rated fully satisfactory in 2015 as a result of its consistent record of worker protection. CNSC staff also continue to rate SRB Technologies' fitness for service program as fully satisfactory as a result of improvements to its manufacturing processes and preventative maintenance activities. In addition, SRB Technologies' fitness for service program meets the requirements of CNSC regulatory document RDGD 210, titled Maintenance Programs for Nuclear Power Plants, which defines requirements for nuclear power plants. As such, SRB Technologies' fitness for service program exceeds CNSC staff's expectations. Nordion received a rating of fully satisfactory for environmental protection due to its continual small environmental releases and Nordion's commitment to the ALERA principle. Nordion's security program was also rated fully satisfactory as a result of program enhancements. Best Saratronics Emergency Management and Fire Protection Safety and Control Area received a rating of below expectation. as a result of shortcomings identified during separate on-site inspections. This will be discussed further in the facility-specific section. Overall, these ratings indicate adequate management of safety and control measures at all facilities. The graph on this slide shows the average and maximum effective dose to nuclear energy workers for the 3 facilities in 2015. The red line in this regulatory is the regulatory annual effective dose limit of 50 millisieverts for a nuclear energy worker. As shown, the average and maximum of dose received by a worker at each facility was well below the regulatory limit. This slide provides the estimated dose to the public from each nuclear substance processing facility from 2011 to 2015. Dose to the public are conservatively estimated for nuclear substance processing facilities primarily by gamma dose rate measurements, air emissions, and effluent releases as applicable. Note that the public dose estimates are not provided for Saratronics because its license activities involve sealed sources and there are no discharges to the environment. Estimated doses for these facilities continue to be well below the limit of 1 millisievert per year. This slide shows the number of lost time injuries for the last 5 years. In 2015, there were no lost time injuries at Srb Technologies or Nordion, and 1 lost time injury at Saratronics. As previously mentioned, Srb Technologies continues to receive a fully satisfactory rating in recognition of its consistent record of effective worker protection. Saratronics was issued its first Class 1B license in July 2014 and was not required to submit lost time injury statistics to the Cnsc under its old license. Cnsc staff conclude that the nuclear substance processing facility licensee programs related to conventional health and safety were effective in protecting persons working in those facilities. In the next few slides, I'll provide some specific highlights for nuclear substance processing facilities in 2015, starting with Srb Technologies. Srb Technologies' license was renewed on July 1st, 2015 for a period of 7 years with an updated license conditions handbook. The license is valid until June 30th, 2022. The Srb Technologies facility is located in Pembroke, Ontario, about 150 kilometers northwest of Ottawa. Srb Technologies processes tritium gas to produce gaseous tritium light sources and also manufactures devices that contain these sources. There were no significant process modifications to the Srb Technologies facility. However, Srb did make some facility enhancements to existing equipment, such as the installation of remote display units to improve Srb Technologies' ability to identify potential upset conditions before they happen, and the replacement of valve types on tritium traps to further reduce small tritium leakages. There are no changes to the license or license conditions handbook in 2015. In paragraph 130 of the record of proceedings for the Srb Technologies license renewal in 2015, the Commission requested that Cnsc staff include in its annual reports more detailed information regarding not only the number of shipments, but the volume of processed material, as well as the number of signs that had been received and how much of that had been directed to waste. As shown in this slide, Srb Technologies made 1,150 shipments containing about 28 million gigabecquerels of tritium processed into gaseous tritium light sources, and received 598 shipments of return devices for reuse or disposal containing approximately 4.7 million gigabecquerels of tritium. In total, Srb Technologies sent approximately 4.3 million gigabecquerels of tritium waste to a licensed disposal facility. In paragraph 108 of the record of proceedings for Srb Technologies license renewal in 2015, the Commission requested that Cnsc staff include in its annual reports a chart with details regarding groundwater monitoring wells. This figure provides the most recent average groundwater monitoring data near SRB Technologies. As expected, the highest tritium levels in groundwater occur adjacent to the facility, and very low values are observed near residential areas and the Muskrat River. The concentration pattern observed in this slide is reflective of aerial deposition rather than groundwater migration. As it rains, the tritium in air is transferred into the groundwater and decays before it is able to travel very far. This means that the values in the Muskrat River are not expected to increase from what is observed today. Tritium values in wells located in residential areas are near or below 200 becquerels per liter, which are well below the provincial drinking water standard of 7,000 becquerels per liter. These residents are connected to municipal water supply, which is fed from the Ottawa River, where tritium is near the detectable limit of 5 becquerels per liter. The observed concentration pattern is consistent with predicted values, and CNSC staff conclude that these residents in the area and Muskrat River remain protected. SRB Technologies did not exceed any regulatory limits. There were no radiation protection action level exceedances or lost time injuries. There was one environmental action level exceedance. The action level exceedance was due to the degradation of a valve and its operation during an inappropriate point in the gas filling process. SRB Technologies' corrective actions include increasing the preventative maintenance frequency on process valves, as well as incorporating procedural changes into their systematic approach to training system. CNSC staff reviewed SRB Technologies' investigation report and proposed corrective actions and found both to be acceptable. CNSC staff are satisfied that SRB Technologies continues to protect the health and safety of workers and the environment. This concludes this section on SRB Technologies. I'll now introduce and discuss Nordion Canada Incorporated. Nordion Canada Incorporated is a nuclear substance processing facility located in Ottawa, Ontario. Nordion manufactures sealed radioactive sources used in cancer therapy, irradiation technologies, and a variety of medical isotopes used in nuclear medicine. The satellite photo on this slide shows the Nordion and Best Saratronics facilities as they are directly adjacent to one another. The Nordion facility is highlighted in the red box. Nordion's license was renewed on November 1st, 2015 for a period of 10 years. The license was issued with Nordion's first license conditions handbook. There have been no major changes to Nordion's facility or its operations since the license was renewed. In paragraph 144 of the record of proceedings for Nordion's license renewal in 2015, the Commission requested to be updated on the proposed disposal of 3 historical neutron sources from the facility. Nordion has been active in identifying an appropriate solution to dispose of the neutron sources. CNSC staff issued Nordion a certificate for the package to be used in the transport of the source once a suitable disposal pathway has been determined. In 2015, Nordion had no regulatory limit or action level exceedances. Nordion also did not have any lost time injuries. CNSC staff are satisfied that Nordion continues to protect the health and safety of workers and the environment. This concludes the section on Nordion. I will now introduce and discuss Best Saratronics Limited. Best Saratronics Limited is a nuclear substance processing facility that is located in Ottawa, adjacent to the Nordion facility. The Best Saratronics facility is shown within the red box. Best Saratronics manufactures medical equipment such as cancer treatment units, as well as blood irradiators. Best Saratronics was issued its first Class 1B license, which included a new license condition handbook in July 2014. The license expires in June 2019. In 2015, there were no major modifications to the BESS Saratronics facility that required Commission approval. 2 orders related to the financial guarantee and fire protection program were issued in 2015. I'll provide details of these orders in the following slides. On August 24th, 2015, Cnsc staff issued an order to BESS Saratronics for being non-compliant with its financial guarantee license condition. The order required BESS Saratronics to divest its inventory of nuclear substances to minimize the liability of future decommissioning activities. BESS Saratronics has made progress on reducing its inventory of nuclear substances. At the same time, BESS Saratronics has increased its financial guarantee to cover the cost of all sealed sources, prescribed equipment, and depleted uranium. In light of the reductions to their inventory, BESS Saratronics has submitted a revised preliminary decommissioning strategy and proposed a new financial guarantee amount, which is currently under Cnsc staff review. Cnsc staff expect that BESS Saratronics will be fully compliant with the financial guarantee license condition by March 2017. An inspector's order was issued to BESS Saratronics in October 2016 after Cnsc staff found non-compliances with the National Fire Code of Canada with respect to a dust collection machine. The order required BESS Saratronics to cease operation of the dust collector to ensure that it complies with the National Fire Code of Canada prior to its use. In response to the order, BESS Saratronics installed a new dust collector and developed a housekeeping program. On November 17, 2015, BESS Saratronics had complied with the order. The corrective measures implemented by the company were reviewed and found to be satisfactory by Cnsc staff. In 2015, BESS Saratronics had no regulatory limit or action level exceedances. BESS Saratronics did have one lost time injury where an employee twisted his knee while walking in the kitchen and supply area. This resulted in a 1-day loss of time. Cnsc staff are currently satisfied that BESS Saratronics has adequate measures to protect the health and safety of workers, public, and environment. The situation with the financial guarantee remains an area of continued focus, and Cnsc staff are following up closely with BESS Saratronics to ensure that it is addressed by March 2017. This concludes the performance review for the nuclear substance processing facilities.
Thank you. Go ahead, please.
Thank you, Mr. President. For the record, my name is Haiti Tadros, and for this next section that relates to the performance of small nuclear research reactors, I will ask my colleague, Mr. Jean Leclerc, to make the presentation.
I guess I should say whether it's good afternoon or good evening. I guess we're getting close to a good evening. Mr. President and members of the Commission, my name is Jean Leclerc. I'm the Director of the Nuclear Laboratories and Research Reactors Division. My presentation will be focused on the performance of small nuclear research reactor facilities. The small nuclear research reactors have been in the landscape within the academic communities for decades to conduct research and in some cases to support industrial activities and produce medical isotopes. There are 6 small nuclear research reactor facilities in Canada. The largest one is located in Hamilton, Ontario. It's the Mcmaster nuclear reactor located at Mcmaster University. In addition, there are 4 Slowpoke Two reactors located in various universities, colleges across the country. There's also a subcritical assembly located at the École Polytechnique de Montréal. As of June 30th, 2016, the subcritical assembly license was revoked, and École Polytechnique's Slowpoke 2 license, PERFP-9A.00, with an expiry date of 2023, was amended to include the subcritical assembly. The small nuclear research reactor facilities are low-power reactors with thermal capacities ranging from 20 kilowatts or 0.02 megawatts for the Slowpoke 2 reactors to 5 megawatts for Mcmaster nuclear reactor. École Polytechnique's subcritical assembly has a near zero energy output and is used for academic purposes, operating about once every 5 years. These low-power reactors are designed with inherent safety characteristics, protecting the health and safety of persons and the environment. The CNSC continuously monitors these facilities to confirm the continuing compliance and safety performance. This table presents the licensing and compliance effort from CNSC staff for small nuclear research reactor facilities during 2015. CNSC staff's primary efforts in 2015 were in compliance activities, which include inspections of these facilities, their activities and processes, and review of licensee reports. CNSC staff performed a total of 7 compliance inspections at the small nuclear research reactor facilities in 2015. All the findings resulting from these inspections were documented in detailed inspection reports that were provided to licensees. There were no major non-compliances. The performance ratings for each of the 14 safety and control areas were determined by CNSC staff based on the results and observations from inspections and desktop reviews. For 2015, all of the small nuclear research reactor facilities met CNSC requirements and received a satisfactory rating, with the exception of Mcmaster nuclear reactor, which received a fully satisfactory rating for the security safety control area. The fully satisfactory rating is due to MNRs maintaining a strong security culture and a best-in-class program to control access to facilities, nuclear material, and prescribed classified information. Overall, these ratings indicate adequate management of safety and control measures at all facilities. The graph on this slide shows the 2015 average and maximum effective radiation doses to workers at the small research reactor facilities. The red line is the regulatory annual effective dose limit of 50 millisieverts for a nuclear energy worker. As shown, the average and maximum doses received by a worker at each of the facilities were well below the regulatory limit. This data demonstrates that doses to workers at these facilities are safe and the radiation protection programs are effective, and perhaps is also a reflection of the generally low risk associated with these facilities. This slide shows the number of lost time injuries for the last 5 years. I believe the table speaks for itself, indicating that over the last 5 years there were no lost time injuries at any of the facilities. The following slide provides the Commission with an update to the status of the public information programs of the small research reactor facilities. In 2015, all licensees actively provided information on the operations of their research reactors on their websites, some including informative videos. Examples of other communications activities undertaken include open houses, facility tours, and participation in community events. The small nuclear research reactor facility licensees have been implementing their public information and disclosure programs satisfactorily during 2015, and their programs are effective at communicating information about the health and safety and security of persons and the environment and other issues of interest about their facilities. I will now proceed with a bit more detailed information for each of the licensees, beginning with the Mcmaster nuclear reactor. The Mcmaster nuclear reactor, or MNR, has been in operation since 1959 and is used for research, materials testing, teaching, and isotope production. In addition to supporting research work of McMaster University students at the bachelor's, master's, and doctorate levels in physics and engineering, MNR is also used for the irradiation of over 10,000 mineral and other samples per year for various applications such as biomedical research, material science, and geological surveys. The reactor is also used to produce iodine-125 for medical use in Canada, the United States, and other countries. MNR is also used for neutron radiography which is performed on a daily basis for testing of aircraft engine components. The Mcmaster nuclear reactor's license is valid from July 1st, 2014 to June 30th, 2024, and there have been no changes to the operations of the facility since the license was granted in 2014. Mcmaster University is currently in the construction phase of the Mcmaster Intense Positron Beam Facility. The project was awarded funding by the Canadian Foundation for Innovation and the Ontario Research Foundation, and will be one of only 4 such facilities in the world and only one in Canada. Mcmaster University was also awarded funding to design and construct a small angle neutron scattering facility, which will allow numerous Canadian and international scientists access to this important research facility. Construction of these facilities is authorized under the provisions of the current license and are expected to be installed between 2016 and 2017. In 2015, M&R had no regulatory limit or action level exceedances. They also had no lost time injuries. CNSC staff are satisfied that M&R continues to protect the health and safety of workers, the public, and the environment. Moving on now to the Slowpoke 2 facilities. The Slowpoke 2 reactors are sealed container in-pool designs with a nominal power of 20 kilowatt thermal. The reactor is housed in a closed container suspended in a pool of water. This restricts access to the core and provides shielding against radiation. Slowpoke 2 reactors provide a source of neutrons to carry out neutron activation analysis, delayed neutron counting, radioisotope production, as well as radiography and radioscopy, and support education and research at master's and doctoral levels in physics and engineering. There were no changes to any of the Slowpoke 2 facilities that would affect systems, structures, and components in meeting and maintaining their design requirements in 2015. There were no changes to the operations of the facilities either. However, University of Alberta has indicated their plan to decommission its Slowpoke 2 facility. The next slide is related to École Polytechnique and will be presented in French. So I'll give people a chance if you want to put on your headsets. Le 2 juillet 2015, l'École polytechnique de Montréal a présenté une demande à la Commission pour que celle-ci révoque son permis d'exploitation numéro PERFP 9.00 et intégrer l'assemblage nucléaire non divergent au permis d'exploitation du réacteur Slowpoke 2 numéro PERFP 9A.00. La demande a été accordée et le permis consolidé a été émis en juin 2016. L'École polytechnique de Montréal a aussi révisé et soumis un plan de déclassement préliminaire et une garantie financière. Le personnel de la CCSN a examiné et accepté le plan de déclassement préliminaire et procède à l'examen de la garantie financière. Je vais maintenant continuer en anglais. In 2015, the Slowpoke 2 facilities had no regulatory limit or action level exceedances. There were no lost time injuries at the Slowpoke 2 facilities in 2015. CNSC staff are satisfied that Slowpoke 2 facilities continue to protect the health and safety of workers, the public, and the environment. This concludes this section on small nuclear research reactor facilities. We're now available to answer any questions.
We'll now proceed with part 4 of the presentation, section 4 of the report regarding Class 1B particle accelerator. Staff, please proceed.
Thank you, Mr. President, members of the Commission. For this last part of our annual report, I would like to ask Mr. Mark Brodeurs to make this presentation.
Good afternoon, Mr. President, members of the Commission. My name is Mark Brodeurs. I am the Director of the Accelerators and Class 2 Facilities Division. I will be presenting the next part of this presentation on the performance of the Class 1B particle accelerator facilities. There are currently 2 Class 1B particle accelerator facilities in Canada. Triumph Accelerators Incorporated is located on the University of British Columbia campus in Vancouver and is Canada's national laboratory for nuclear and particle physics research and related sciences. Canadian Light Source Incorporated is located on the University of Saskatchewan campus in Saskatoon and operates a synchrotron facility. The facility produces synchrotron radiation that is used as a light source for experiments in diverse scientific fields. The CNSC continuously monitors these facilities to provide assurance to Canadians of the continuing compliance and safety performance. This table presents the licensing and compliance effort from CNSC staff for Class 1B particle accelerator facilities during 2015. CNSC staff spent a total of 20 person days on licensing activities. A total of 303 person days were dedicated to compliance activities, which include inspection of these facilities, license activities and processes, as well as desktop reviews of licensee reports. CNSC staff performed a total of 4 compliance inspections at the Class 1B particle accelerator facilities in 2015. All the findings resulting from these inspections were provided to the licensee in detailed inspection reports. The performance ratings for each of the 14 SCAs were determined by CNSC staff based on the results and observation from inspections and desktop reviews. For 2015, the Class 1B particle accelerator facilities met or exceeded CNSC requirements and received a satisfactory or fully satisfactory rating accordingly, with the exception of one below expectations rating for failing to meet CNSC expectations. The basis for the below expectation rating will be discussed later in the presentation. Overall, these ratings indicate adequate management of safety and control measures at all facilities. The graph on this slide shows the average and maximum effective radiation doses to nuclear energy workers for 2015 for Triumph and CLS. The red line represents the regulatory annual effective dose limit of 50 millisieverts for a nuclear energy worker. As shown, the average and maximum dose received by a worker at each of these facilities was well below the regulatory limit. This data demonstrates that dose to workers at Class 1B accelerator facilities are safe and their radiation protection programs are effective. This slide shows a number of lost time injuries for the last 5 years. The injuries which occurred were not specifically related to the licensed activity, but rather were occurrences that may happen in any ordinary laboratory or administrative office environment. CNSC staff conclude that the Class 1B particle accelerator facility licensees program related to the Conventional Health and Safety SCA were effective in protecting the health and safety of persons working in those facilities. In the next few slides, I will provide some specific highlights for the Class 1B particle accelerator facilities for 2015, starting with Triumph Accelerators Incorporated. There were 2 reportable events in 2015 at Triumph. One was for a non-nuclear energy worker having incurred dose in excess of the Triumph quarterly action level while carrying out work during shutdown. The other event was an accidental release from a rubidium target. Triumph investigated both events to determine root causes and implemented corrective action. CNSC staff have reviewed and accepted the corrective actions that Triumph has implemented. In 2015, Triumph had no regulatory limit exceedances. Triumph had 4 lost time injuries in 2015, totaling 9 days of lost time. CNSC staff find that actions taken by Triumph to be acceptable and are satisfied that Triumph continues to protect the health and safety of workers and the environment. This concludes the section on Triumph. I will now move on to Canadian Light Source Incorporated. CLS received a below expectations rating for the Human Performance SCA in 2015, as mentioned earlier. This is based on an inspection conducted in May of 2015 that found there had been no progress on the systematic approach to training-based training system. The inspection noted that the required analysis had not been performed, and further, that the CLS training system was not adequately reflected in an overarching training system manual with supporting procedures. In April 2016, CLS submitted a status update to the Cnsc, including updated programs that address the non-compliances. Cnsc staff reviewed and accepted the updated programs, which demonstrated significant progress in addressing this issue. Cnsc staff will verify the implementation of the SAT through an on-site inspection scheduled for the next quarter. I will inform the Commission on the results in the 2016 Regulatory Oversight Report. In 2015, CLS had no regulatory limit or action level exceedances. CLS had one lost time injury leading to 2.5 days of lost time. Cnsc staff have reviewed the event and are satisfied that CLS continues to protect the health and safety of workers and the environment. This concludes the section on Canadian Light Source. I'll now turn the presentation back to Ms. Haiti Tadros.
So for our final slide, and in conclusion, Haiti Tadros for the record. Cnsc staff compliance activities across uranium processing facilities, nuclear substance processing facilities, small research reactors, and Class 1B particle accelerators during 2015 have confirmed that radiation protection programs adequately controlled radiation exposures, keeping doses as low as reasonably achievable. Environmental protection programs are effective in protecting the environment, and overall, conventional health and safety programs continue to address the needs of workers and protect them. Cnsc staff conclude that in 2015, each facility made adequate provisions for the protection of the environment, the health and safety of persons, and the implementation of Canada's international obligations. Thank you for your attention. We're available to take questions.